everybody. Good morning. And this is, Yanni is right, this is a sequel to a talk. And so, my name is Shawn. I go by Swix on the internet. I work at Netlify as a developer experience engineer. It's the best place to host your React apps, hint, hint. I also help to moderate the r/react.js subreddit, where there's over 140,000 of us talking about React, sharing about React, posting jobs. And of course, last night we were very excited about the release of concurrent React and hooks. And suspense. I'm sorry. I'm a little bit nervous right now. And also, I'm a big proponent of learning in public. And so this talk and everything that I do is really just about sharing everything that I've learned in a concise way, sharing what I know, and hoping for honest discussion. And I think you'll find this very much in that same vein. And I also have a confession, which is that I have a problem. And the problem is that I signed up for something which is no longer a fit. So I'm supposed to come here and tell you about React hooks. I'm supposed to tell you what they are. And I think, does everyone here, have you all used hooks? Yeah? Yeah? All right, cool, awesome. I'm also supposed to tell you about the rules of hooks and what happens when you break them. Basically, Dan comes over and racks you on your knuckles. I'm supposed to tell you about closures and why that's an issue that you run into when you're using hooks. I'm supposed to tell you what closures are, because a lot of people aren't familiar with them. I'm supposed to write hooks from scratch. And then in my talk description, I promised to write a hooks clone, a React clone, I guess, in 29 lines. You can count them. It's 34 minus 5, 29. And this single module is enough to write an app with JSX, with hooks, with effects, with custom hooks. And you can live hit an API and interact with that user interface that you're writing in something that looks like React. So that's the talk that was promised. The only problem is that I already gave this talk. And so when I actually talked to the React Advanced people, this is the only talk I had, so I was like, I'm just going to resubmit. But with your permission, if that's okay, I want to do something that is even more ambitious than this. I heard that we're supposed to be diving deep. So is everyone cool with me diving deep? Yeah? Yeah, thank you. All right, yeah, you asked for it. So instead of React with hooks from scratch in 29 lines of code, I think I want to be a little bit more ambitious and talk about concurrent React in 130 lines of code. And I think this is important, right? I think now we're starting to need to know what React Fiber is, what concurrent React is, because it's launched, because we can actually start using it now. So hopefully this talk is the talk that sort of helps you get started on your way to understanding the mental models behind all of this stuff. Again, I'm less qualified to do this than the previous talk, but whatever. I'm learning in public, and I think I have something really awesome to show you. So what are we going to cover today? We're going to cover what React Fiber is. For those of you who are kind of vague on it, it's like a rewrite, sure. We're talking about rendering. We're talking about what React has to do with linked list traversal, and why is that even important? What is reconciliation phases versus commit phases? How do we add a use state hook under all this framework? What is the work loop? What is time slicing? What is suspense? And we're going to do that in 30 minutes. You think we can do that? Yeah? First, I want to acknowledge the people who've come before me and the people I borrow a lot from, particularly Rodrigo Pombo. He's done a lot of work on Didact, which is his clone of React. A lot of code and ideas come from this, as well as Andrew Clark's notes on what React Fiber is, as well as Lynn Clark's talk at React Europe, which I highly recommend as required reading for anyone diving deep on this stuff. All right, so let's get started. Let's reintroduce by starting at something you're probably more familiar with, a JSX element. A JSX element is a plain old JavaScript object. Only has two fields, or two important fields, types and props. And it kind of looks like that, right? Except that most of us don't write that. We use a helper like a react.createElement. But under the hood, that's what it is. It's just a plain old JavaScript object with type and props. So a fiber is an extension, I guess, of this element. And we had a whole bunch more properties on top of that. So we had a link to a DOM node, like an actual physical DOM node. We had links to parent fibers, child fibers, sibling fibers, all over the place. We had links to an alternate version, like the work in progress version of the fiber. We had hooks in case if anything is tagged onto that. And we had an effect tag if that fiber itself is tagged for any additional work during the reconciliation phase. So that's what a React fiber is in your mind. It's a data structure containing everything that React might possibly need to know. And this is immensely helpful, even being used by the dev tools to do things like the new filtering feature that Brian Vaughn introduced. So let's write it. So I'm going to confess that in order to get so much code done, and I saw someone's request for a light mode, so we're going to do light mode. In order to get so much code done, I'm going to do a bunch of copy-paste, but hopefully it's followable enough because I've tried to really sort of pare this down so that you can follow along. Here I have a blank index.js page, and the only utils folder I have is 130 lines of helper code. And you don't worry about this. I'll release this later on, don't worry. And I'm going to start off with a blank index.js page. It's got some nice CSS for animated gradients just because I like that. Makes me look like I know CSS. So the first thing we're going to do is initialize some stuff. And so here I'm going to import my utils, the 130 lines of just like helper code for like create element and stuff like that I don't want to write. And then I have some global pointers. Like for the next unit of work, I'll explain what that is. The root fiber and the work is I'm sorry, the root fiber and the work in progress fiber. And then also a React module, which currently only has react.create elements so that I can actually use JSX, which I have enabled. I have no dependencies here except for Babel. All right, so the next thing I'm going to do is I'm going to write a fiber. Again, it has types and props. I don't want to screw that up, so I'm also going to paste that in there. And so here what we have is a fiber. This is the work in progress root fiber. I'm just going to start with that and hard code it. Later on, we'll generate this. And attached to that, I have the DOM node, which is the container, which is document.getElementById. Everyone's familiar with this. And then the only children of that work in progress root is just the element which we want to render. In which case, this is h1 hello world. Everyone's familiar with this, and I can actually, because I have react.create element defined, I can actually just swap that out with this thing, and that should be fine as well. Okay, so this is a little bit closer to what the React that people are used to. All right, so that's it. That we've written our first fiber, which is very nice. Unfortunately, we have to turn everything else below it into fibers. So we'll get there. We're not going to go there yet. First, I want to just get something on the screen. So I'm going to paste in a simple render function. And this function, basically all it does is it just creates the DOM nodes, right? It takes the element, creates the DOM nodes all the way down recursively. And it recurses through all the children to create all those DOM nodes. And then it appends them to append child to the container. Does that make sense? Yeah. So very simple render function. And so far, all we've done is like very, very small lines of code just to get this basic data structure onto the screen, right? But you can already see the mental model of like create the thing, then render the thing. So that's very good. And let's talk about the weaknesses of this approach. So I'm going to switch back to my slides. I think I have to play this. All right. So right now we're rendering, and this is how it looks kind of under the hood. And so imagine a tree just like with a div, an h1, a ul, and an li. This is kind of how it looks right now. Well, it's kind of small, and yeah, I didn't really choose the contrast very well. But this is meant to indicate that we're doing work. We're doing the rendering work. We're doing the rendering work, and then we're doing the committing to the DOM. Right? So we move from the root down to the div. When we do that work and we commit to the DOM, we move to the h1. We do that work, commit to the DOM. We move to the ul, do that work, commit to the DOM. At any point in time, a user can come along and look at the at the page and see a broken state. Like, I've already updated some of these paths, some of these nodes, but not all of them. And so that's a problem for user experience. Anyway, we'll just keep going. Move to the LI, commit to the DOM, move to the LI, commit to the DOM. So obviously, that's a very naive rendering approach, and that's what we've implemented so far. I think I'm going to skip a few steps and go towards something more robust, and let's call that reconciliation. So here I start off with, and this is all done with fibers. So here I start off with a work in progress route, and I'll define doing work as a unit of work, processing one fiber, which is analogous to one DOM node over here. So I perform a unit of work on the top div. Then I move to the first child. Every fiber has a first child, and if there is a child, I'm going to move to that as a first priority. Then I'll process the H1. Then I'll move to the first sibling, because that H1 has no child, so the next rule is that I move to the sibling. Then I look at the UL so far, and then the user comes along, and the user doesn't see anything because I haven't committed to the DOM, right? So that's good. And so then I keep going. I can perform that, continue performing that work on the first child of the UL. The LI doesn't have a child, so we perform the work on the sibling. This last LI does not have children, does not have siblings, so we just recurse up to the parents. So we just go all the way back up to work in progress route, and that's how we know we're done. We've iterated through this entire tree structure, and by the way, the big O of this is O of n, and that's a big saving in terms of performance from true tree diffing, which is O n cubed. Anyway, so now we have a full, so all this is rendered as alternate fibers, and so now we have this full thing in memory, and then we can just move that and commit that, and this save icon is meant to indicate that we're committing. Again, I'm not the best artist, I'm not like the best in visuals, but hopefully this, I felt like I needed this to explain what's going on in my head. And so once we commit it, we can actually flush everything to the DOM. Hopefully that makes sense, and so the user just sees one contiguous change from the previous state to the next state with no tearing in between. That's important for React. We want to always have the guarantee from React so that we as app developers don't think about it. Okay. So for this is the linked list tree traversal, and this is one of the core algorithms that you might want to bone up on if you want to look into fiber, and that's the issue on the React repo if you want to follow up on that. I think I should have to go back now and figure that out. All right, so. So we're still at the simple render in our code. Let's actually swap that out for an implementation that involves reconciliation and committing, right? We've established that is better. So I'm going to delete everything that I've done here. And yep, okay. All right, okay. So, and then I'll paste in the reconciliation code. It's going to look big, but once I minimize some of the big parts, you see that it's actually kind of simple. So we start off with a null next unit, next unit of work. We start off with just like the next unit of work being the root, right? And while there is a next unit of work, we will just infinite loop. We perform that unit of work, right, which is reconciling. And we'll just keep going until it returns nothing, until we've just reached back to the original root. And then we commit the work to the DOM. Right? This exact model that I've shown you. Inside of perform unit of work is a bunch of things involving handling what a function component is versus a host component. Don't worry about that. But it is recursive all the way down, and using the reconcile children function from the utils. You don't need to worry about, except that I guess you should know that this is where the new fibers are created. So you want to run them through once to get all the fibers, and then you run them through each time to get the new fibers and diff them. So that's roughly what we're going on. Roughly what's going on here. Just to let you peek under the hood of commit work as well. All we're doing is either append child, update DOM, commit or commit deletion. That's about it. And then we do the same thing for all the children and sibling. We can do some more work to chop this up, but I'm choosing not to do that right now. So that's the rough idea. We're doing this reconciliation and committing phase. So then now we come to the concept of a work loop. And honestly, I was a React user for probably 2 years without even knowing that there was a work loop. And once I found this out, I was actually a little bit I don't know. I was surprised this worked. So this is analogous to a game loop. Right? You just have to have a running loop to figure out what the program has to do next. And that comes to do with this because basically we're starting from a work in progress root, and then we run this loop once. We reconcile everything, we commit to a DOM, and then that's it. There's no way to restart this whole process again. So I need to wrap this in some sort of function that just calls itself and calls itself and calls itself and calls itself. So that is the work loop. So I'm going to swap this out. I think I'm doing this here with a work loop. So you can see the same code nested inside of here, where we're showing this next unit of work. And also committing that work. But the relevant bits to focus on are the request idle callback calls. So a lot of people may not use request idle callback on a daily basis. That's perfectly fine. This is kind of like set timeout, except that it has a slightly different signature with regards to the callback that is given. So the callback is passed an idle deadline object. And the idle deadline object only has one method, which is the time remaining property. And so you want to call this to figure out how much time is left in this callback before you yield back to the browser. So anyway, so that's the work loop. I can go into that, right? Yeah, so let's go into time slicing that work loop a little bit. This is actually very, very easy in this simplified model. So I just want to show you how cool this is. So because we broke everything up into a unit of work with a singly linked list, with a linked list, and then we're just performing it iteratively, we can actually do this. So we can say like that should yield equals false. So we can just determine whether we should yield or not. And the way we determine that is we'll let should yield equals to deadline, which is the argument that I get back from request idle callback. Deadline time remaining under 1. So if there's less than 1 time remaining, then we'll just yield back to the browser, right? We'll stop doing more work, and then we'll pick it up again when the next time we're called again, right? And then we'll just chuck that in here. While there is still a next unit of work, and it's should yield equals false, then we keep doing work until such time that we should yield. And that's it. That's a very basic time slicing example. And so what that does, I think this is very powerful. So what that does is it switches React's model from the sync mode up top, where you're just doing a bunch of all the rendering work up front, and then you commit, to a model where you can actually chop things up to 16 millisecond intervals, or whatever your sort of idle callback rate is, right? And so that makes your app a lot more responsive by default. And also, you can add in extra priority levels to interrupt your rendering. We're not going to do that today. But this is real. This is not just a graphic from Andrew Clark. This is actually something that you can see in the Fiber demos. Go do the before after, because now you can do it. Switch out the roots. Where previously, for an expensive tree, you had something that looked like this, where it just blocks the thread for the period of render. Now it can actually chop it up into individual cycles and yield all the way back. And then once you have another idle callback, you start work again. This makes sense, right? Okay. So now let's talk about a useState hook. I'm kind of bored of just showing hello world there forever. And so this one I'm going to cheat a little bit. So I'm going to rely a lot on the fact that this keeps getting run, right? And the main things that make it work is that there is a next unit of work. If next unit of work is falsy, then we're not going to run. We're not going to do any work. And the other thing that's sort of hidden here is that we're not going to commit unless there is a work in progress root. All right, so I'm going to add a useState function over here. And so this one has a bunch of code. Notice this fun operator. Does anyone know what this is? Optional chaining. The better name for this is Elvis, and he should always use that. I just wanted to show it off. That's all. It's cool. Anyway, so the use state, we pull off the state from the old hook. We compare it, and if there is a pending state, we commit it, and then we actually render it. All of this is sort of standard, hook replication state stuff. That's what I did in my previous talk as well. You can go check that out. But I want to draw your attention to here, where if the user calls set state, internally what we're going to do is we're going to just schedule it schedule an update. So we're going to pass that set state into the pending state. Then we're going to make a work in progress root fiber, and we're basically just cloning the current root. And so now we're setting things in motion by activating the work in progress root and telling our React that there is a next unit of work. And so that's actually what calls the set state. So let's actually see this in action. I'm going to attach this onto the React module that we have going on over here. And I'm going to have a little app. All right, so I'm going to get rid of this. Actually, I don't think I need that. Yeah, all right, I'll just get rid of that. Let's have a demo app just to see this working, because I like to see things working. All right. Okay, I think I deleted too much. All right, so this is a basic sort of React app, right? That uses uses the useState hook that we just wrote, has some basic JSX, and we're using that rendering method and that work loop to render this. So every time I click, it schedules. It's able to pick up what is the changes that's been scheduled. And this is always like the hello world of like, hey, I made a framework now. But hopefully that makes a lot of sense, and I've introduced it in a logical fashion, because that matters a lot to me. Oh, yeah. Then we're also going to talk about create root. I'm sorry. All right, I changed the order a little bit, so I'm a little bit out of touch. All right, so now the problem is like I set up the roots this way, and like that's not the way that we write React apps, right? We don't really initialize them like this. So I want to create a helper, and so it kind of looks like that. We call like a render function, right? That's what we do in React. So render element container, we create the work in progress root, and then we set a next unit of work. Very, very standard stuff. Whenever you want to kick off a render, that's what you do. So render element container, and then you have this stuff. Well, the new API is slightly different for concurrent mode. So instead of calling a render function, we actually have a create root function. So it's something like this: create root element. It calls it on a container. Then we return an object called render. And then that takes an element. And then we just take this whole thing here, chuck it in there. There you go. And instead of render element container, now we say create root container dot render element. So everyone who looked at the concurrent mode docs yesterday should be familiar with this, where it's instead of calling render element container, it's create root element. Yeah, it's just meant to be slightly easier, especially if you're creating multiple roots. And there's different modes as well, so be sure to look at the blocks mode. So all right, so that's a rough picture of clone of React, and I'm almost done, which is good because I don't have that much time. I'm going to take out. I'm starting to get a little bit messy. I'm at 138 lines of code. Starting to get a little bit messy, so I'm just going to chuck this into a module somewhere. Guess what I'm going to call it? react.js. Yeah. Why not? All right. Let's take this whole thing. Cut. Paste. Expose, create root, export const react. Get rid of this stupid thing over here. And then I'm just going to copy and paste All right, so now I have sort of separation of concerns, whatever you call it, and I can import the React, the fake React, faux act, import React from React. I can call react.createRoot, not render, and I have a working app. Isn't that weird? Look at my dependencies, it's just Babel. What? This is cool, right? But it's not cool enough. I still have 5 minutes. What am I going to do with that 5 minutes? I know. There's this new feature that was launched. Am I dumb enough to try and do this? I think I am. Again, this is very much cutting edge for people who, I mean, we're supposed to go deep. Cutting edge for people who are interested in suspense with data fetching. Definitely check out the docs. But don't do it the way that I do it, which is I go to some of the patterns, right, and then Dan spend an amazing 48 hours on this, and he writes like 10 different demos on how to use them right, except that he warns you inside of his fake API over here, don't copy paste this into your project. I'm sorry, but I copy-paste things my whole thing right now. Anyway, so yeah, let's just copy and paste it. Why not? I have a fake API.js file over here. I'm going to paste that in there. All right, and then I'm going to swap out the app over here. And let's see what I got for you. All right, so for those people who know, the suspense works by throwing a promise, as of right now. That's an implementation detail, of course, and it might change. And right now, it's throwing that promise, and those promises are getting run because of the way that he implements his resource. But there's no way for me to re-render on the promise, on the thrown promise. So I do need to try and catch this somehow. So I'm going to go into the way that, for where you want to catch is basically where you should process the promise. So I'm going to try and go into this perform unit of work, because it's going to process each component as in turn, right? So in theory, I could just throw a try catcher on this. And I should show you the API. So sorry, I skipped steps a little bit. I should show you the API that I'm coding to. So this is a fake API. This is a promise that's being run, and he has this wrap promise function over here where you wrap the promise call, and over here it kind of just listens in and then saves the result once the promise is resolved. But while it's pending, it throws the suspender up. So we need to write something to catch that promise, and then just run that promise. So I'm gonna catch the promise. So if the error is instance of promise, I actually kind of hate using the instance of keyword, so because it's so different from everything else. I'm gonna just rethrow anything that's not a promise, because why not? And I'm gonna just go error.then. And then I'll do something, right? I'll actually run the error and then .then it, and then schedule it for updating a function. Hey, it's already picking up over there. So the ideal way for me to do this is that I should actually try and suspend the work somewhere. So the way that I implemented it here, it's absolutely not the right way. But just humor me. So I'm just having a placeholder for how to hold on to the suspense. I'm going to freeze that. I'm going to save that in the next unit of work, and then I'm going to nuke the next unit of work so that I don't keep rendering while this thing is going. And when the promise is resolved, I can restart it by doing the same thing that we've always been doing, restarting the next unit of work, as well as the work in progress route. I'm cheating a little bit here by setting it back to the current route to just force a re-render of the whole app. Again, this is not the best code, but it's the best that I can do. I may have broke the whole thing. Oh, did I break something? Yeah. The hot reload in Code Sandbox might be a little bit problematic sometimes. Yeah, there you go. So now I have a count updating and then suspense data fetching on the render. So all of this, there's no sort of the whole idea of suspense is that there's no custom like use effects, dance back and forth with state and all that. You just declare a resource and then you pull it in as a result of the render. That's not the official way to use it. You're actually supposed to use it with relay apparently. But this is just a rough idea of like when you know the internals well, you can modify like we modified like 4 lines of code, and you have the rough idea of like where to touch it to really sort of capture the effect. And so just to sort of simplify it for you as well, just because I love doing this, I have a slightly simpler API, a mock API. This pings a function that I set up on Netlify because it's easy. But one thing I did over here that's different is that I made the read method over here parametric. So I can actually pass in an ID to fetch, and it does that fetch for me. And so I can swap out my implementation of the fake API over here, and just use like a dog app. Again, I'm just swapping the UI out, and I'm pinging that API. And this is what the this is where we were before the current release. We're still trying to figure out what the right usage pattern is. But inside of this app, we have a very clean, like we're using the state. We're reading from the resource, and that resource suspends as needed, or it caches as needed. And then we just display it inside of our render. So even though we're doing a bunch of async stuff in here, it actually is working very well as a suspense clone, I guess. So yeah, I mean, that's the rough idea. I mean, you can go on and on and on cloning this, and eventually you end up with React. And so that's just a quick recap of what we covered. We covered React Fiber, we covered rendering, we covered linked list traversal, reconciliation versus committing, hooks, work loop, time slicing, suspense, grand tour of everything that like you might want to bone up on as you sort of dive deep into React. But this is all the stuff that we did not cover. I think DevTools is a really important part of React. And I actually forgot a few things over here. There we go. And one of the things I particularly did not cover is also the 2 new hooks, use transition and use deferred value, that we got that you should use together with suspense. That is an exercise for the reader and the viewer, but hopefully I give you some inspiration as to like what React internals, like a mental model for how React internals work and what concurrent React can promise for you. Thank you very much. This talk will be up on my site.